Hello, ma'am. Myself Gautam, and I am from CSC A section. And my CA2 assignment is about the click decision problem. Click decision problem is nothing but it is a graph problem. Brief decision problem is a fundamental problem in graph theory that involves identifying the largest clicks or fully connected subgraphs within a given network. This has important applications in fields like social networks analysis, bioinformatics, and computer science. So this click decision problem is work on the graph theory in which the graphs should be in a closed manner, so that the graph should be complete, and in how many nodes the graph is complete. So that is called as click. That is, if we consider an graph with the three nodes and it is completely complete graph, so we can say that the click of the graph is n equals to 3, and the decision problem is nothing but whether the click is true or false. So that the total click decision problem says that whether the click is true or false. This can be known using the and or notations, and we should connect the nodes, that is x1 x2 x3 and so on, should only connect with x1 to x1 or x1 to x2 x1 to x3 x1 to x3 x1, and also, and we should not connect with the negations, that is x1 to x1 x1 bar, x2 to x2 bar, x3 to x3 bar. So let us know in detail about this click decision problem. Actually, we should learn about the graph theory before knowing about the click decision problem. Introduction to the graph theory. Graphs and vertices. Graphs are mathematical structures composed of vertices that are called as nodes, and edges connections between the nodes. That is, if you consider an x1, x2, x3 are the three nodes, so the connections between these three nodes is called as edges. And adjacency and connectivity. Vertices that share an edge are considered adjacent, and clique is a subset of vertices where all the pairs are adjacent. As previously said, it tells about the adjacency and connectivity. So graph algorithm. Solving graph problems often requires specialized algorithm to efficiently traverse, analyze, and optimize network structures. And defining the click decision problem, as I mentioned in the first slide, that click is a uh, subset of a subset of a graph which has complete graph. And input, let us take an example, a graph g, and an integer k. Here k is nothing but 1 2 3 and so on up to infinity. Question: does g contain a click of size k or greater? So here the g is a node, and the size where the click is size of k or greater than or less than. So goal, our goal is to determine whether such a click exists in the given graph. As I mentioned, decision is nothing but true or false, and the challenge, the problem is NP complete, meaning to the no efficient algorithm is known. So at last we should know that the an efficient algorithm is present for the problem or not. So brute force approach: generate all subset, enumerating all possible subsets of a vertex in a graph, and check for clicks for each subset. Verify if all vertices are pairwise adjacent. So I mentioned that we should check for clicks. So firstly, we should generate all the subsets from a graph where the nodes, that is, we have five nodes, so that we should mention all the complete nodes from these five no, nodes. That is, we can have five nodes complete graph, three nodes complete graph, two nodes complete graph. So we should generate all these subsets and check for clicks whether the click is present or not. And return results: report the largest click found or index size k or greater exists. So at last we should consider the greatest click, that is k is a greater value, so we should consider that values. Next, we'll go for next slide. Efficient algorithm for click detection. Broncop's algorithm, and a recursion backtracking algorithm that efficiently enumerates all maximum clicks. This is one type of algorithm. And Sukiyama's algorithm, an algorithm that uses a clever data structure to find all the maximal clicks in a polynomial time. And approximate algorithm, technique that provides probably good appropriate solutions when an exact solution is intractable. So these are the efficient algorithm for a click detection problem. And complexity analysis and the practical considerations. Computational complexity. The click decision problem is NP complete, meaning there is no known efficient algorithm to solve it. So it means that the efficient algorithm is not found to the click decision problem, that is NP complete. So next, second one is heuristics and trade-offs. In practice, researchers use a variety of techniques to balance speed and accuracy for specific applications and real-world constraints. Factors like graph size, density, and application domain can significantly impact the efficiency of click detection algorithms. And by summarizing all the slides, so we can share that the click detection, and I will once again repeat what we have learned up from all these slides. The firstly, the clique decision problem, where the clique here is nothing but the greatest subgraph from a graph which has complete graph, so it is called as clique. And clique decision problem, so decision is nothing but whether the clique is present in true or false. So and we also prove that the NP complete. So NP complete is nothing but there is no efficient algorithm to solve the click decision problem. So click decision problem will work like when we consider an three nodes, that is x1, x2, x3, and these three are connected in a triangular manner, and this is a complete graph. So here the clique is n equals to 3, and we should prove that we should prove that with a formula, that is f of x1 comma x2 comma x3, that is x1 and x2 x1 or x2 and x1 bar, that is x1 complement or x2 complement and x1 union x3. So we should consider from we should consider from this from main graph, so that we should solve these all these equations. So we should get the maximum click, where we have got the maximum click n equals to 3. So whether it is correct or not, we should find with the formula I have said, f of x1 comma x2 comma x3. So if it returns 1, so in truth table we all know that 1 is for true and 0 is for false. So it will return true if the clock is n equals to 3. So if it not true, so it will return 0. Likewise, we can summarize all the nodes from the main graph, and we can find the clicks for it. And we can also prove it with algorithms I mentioned previously. And complexity analysis and practical considerations I have mentioned now only. Real world constraints, factors like graph size, density, and application domain can significantly impact the effectiveness of click decision problem. So all these factors will affect on the click decision problem, whether it increases its efficiency or decreases its efficiency. Let's go for next slide. Real world applications for click decision problem. So social network analysis, identifying the tightly knit communities and the influential groups within social networks. Uh, Bioinformatics, discovering protein complexes and gene regulation modules from biological interaction data. Computer science, we all know that computer science also works on these click decision problems, optimizing resources, allows and scheduling problems, modeling as a graph. So all these are the real world applications for click decision problem. And thank you. Thank you for your valuable time and spending your time for my PPT. And I hope I have made some mistakes. I know I make mistakes. Please forgive me for that. And I hope the PPT is very clear, and I have given somewhat knowledge to you. And this is all about the PPT click detection problems. And thank you once again. Thank you for this opportunity. Thank you.